morning. Mic is on. Okay. Yes, it's working now. Okay, so I have set up a small laboratories to just look at some of the experiments and see. The reason why we are doing is how to learn chemistry with experiments. So we'll do some few experiments. So I'm sure, if not all, some of you are aware of what is shown there. Are you aware of iodine test? Please say it loudly.
Yes, sir.
You do in BSc or MSc laboratory, right? This is also used in kitchen to find out whether the potato, this thing, starch. There are various sources where starch is there. So now what we want to do here is to understand how starch, the starch iodine complex forms and why it shows color and how we can kind of track that. Okay, so let me briefly first tell about the chemistry component of this. If you see this, here I have here I have, no, it's not the one. The bigger one. Okay, if you see a helix here, this is the structure of starch. A starch is basically a polysaccharide. You see there are two components of a starch. One is called amylose and other one is amylopectin. Now for the formation of complex, we saw the color, blue color. I'll demonstrate that later. The picture on the left, amylose is the key. What it does is, it's a linear chain of, there are monomers. Are you aware of monomers of starch? Is a cyclic structure, right? And the several cycles join and form a chain. And in biological system, if you aware of the DNA, RNA, they never became a straight chain. They either form a kind of a ternary structure or they form helix and so on. So this is one of the helix example. Now this helix is the schematic shown here. Helix has a cavity. There is just like spring you use in the ink pen or the pen with refill. You use a small spring. It exactly look like this in the small scale, at the atomic scale. Now, because this is a helix, there is a cavity. In that cavity, iodine goes inside, and then the charge transfer happens. So you see a color. Okay. So one of the experiments that we do is called iodine cloak experiment. So you can track this complex formation by monitoring iodine concentration in terms of time. So let me start that. So I have 5 solutions. I'm making different with different concentration of iodine. So what I'm doing is I'll make 200, in each beaker there will be 200 milliliter solution at the end of the experiment. And the calculation is such that I have potassium, the very first, you see there is a Ki, there is a source of iodide, Ki, okay, potassium iodide. When that reacts with sulfuric acid and hydrogen peroxide, it gives you molecular iodine. That's the you are aware of iodine, right? This is a volatile gaseous stuff. So in this whole thing, the first reaction is rate determining step. Are you aware of what is rate determining step in chemical kinetics? Yeah, please say, what is that? Louder. You can stand up and say, that will be so nice. The step that is slower is rate determining step, right? It's always the slower one which determines the rate. So in these two reactions, first one is rate determining step, and in that step iodine forms. So now what I do is I have a table there. It's also on the computer, but I'll Am I audible?
Yes.
Okay, great. So, so he is feeling what is that. I made table on the screen, you can see. And what I am doing is I am adding sulfuric acid. Okay. Have you seen sulfuric acid? Your laboratory has it. So 1 mole of sulfuric acid, how many moles of acid protons it gives? How many moles of protons you get out of 1 mole of sulfuric acid? If you make a aqueous solution. Anybody? What is the formula of sulfuric acid? H2O. So there are 2 protons, right? The moment you make a solution in water, you will get 2 protons. Meaning 1 mole of sulfuric acid will give you 2 moles of protons. Okay. Now I have a solution of star here. Where do you find starch in natural sources?
Potato. Is there any other source? That's very good. Yeah. Any other source of starch? Corn you eat, right? Hmm? Rice. You eat corn also, rice, right? So since this is a chemical kinetics experiment, we need to be very careful about concentration, because chemical kinetics, what are the orders of the reactions you see? You see order of reaction. What are those? Zero order, first order, second order. What does zero, first, second, how you define that? It is how it depends on the precursor, right?